Good morning, Barcelona. Try that one again. How are you all? Hope you are enjoying GrafanaCon. We're going to be talking through lessons from a security incident where everything went wrong. Really, almost everything that could go wrong did go wrong, but it all ended up right in the end. So my name's Nick. I'm a principal security engineer at Grafana. I'm in the detection and response engineering team, possibly a team we named purely for the abbreviation. I can't confirm or deny that. And when I'm not busy tracking down people trying to hack Grafana, I do actually like doing a bit of running. I like going up and down mountains. I've run up and down the hills around Barcelona already, and occasionally run further than most people like to drive. And I'm joined here by
David. First off, though, a little bit of running. That's a euphemism for 180 miles a couple of weeks ago.
Yeah, something like that.
Somewhere there around. Good. So yeah, David Anderson. I work at the security engineering team at Grafana. We don't have such a fancy abbreviation, but we do everything from secure best practices, how to implement secure coding principles, and these kind of things. Not as avid a runner, but I like to be on stage, mostly singing, dancing on occasions, and also enjoying sitting in the audience, enjoying musical theater. All right.
So we're going to take you through a Saturday morning. Do you hear that, David? It sounds a bit like a canary singing. Well, it was an otherwise normal weekend. We woke up, we got up, we looked at our phones and went, that's a weird alert. I've not seen that one before. Two eagle-eyed security team members just happened to notice a particularly concerning alert that had popped up. And normally we don't worry too much about this, but this was a big one. It was actually indicating that there was a complete CI/CD compromise. All of our GitHub secrets had been exfiltrated by an attacker. And at that point, most organizations are going, oh God. In fact, most people, anyone, is thinking, oh God, this is the worst possible outcome. But yet, in fact, we were able to write, very shortly after actually, that there had been no customer or user impact whatsoever. We were able to show nothing had actually been done with those secrets that had actually had any outcomes. But we're going to tell you that story of how we got there, the problems that we encountered at the beginning, how it happened, and then how we investigated, rectified, and the changes we made to make Grafana more secure. So I'm going to hand back to David.
Thank you. Before going into the details of the actual hack and the actual incident, I want to talk a bit about these two triggers. So for those of you who have worked with GitHub, you're aware you have two triggers that you can use when responding to a pull request in GitHub Actions. One is pull request. The other one is pull request target. They look so alike. They are, in fact, not. So pull request, this is a safe default. You're in your developers, your fork maintainers, what have you, the one forking your code, they run their workflows in their context. It's a safe default. No access to your environment, no access to your secrets, all fun. Pull request target, not so much. Immediately, they have access to your repo with your secret, and it becomes your problem. So it has a legitimate purpose. It's designed for maintenance tasks, automated, labeling, these kind of things. But the thing is, when you combine pull request target with something that a user can control, all of a sudden, the fork code becomes trusted code. So this small change here is the gap between looks safe and is safe. Fast forward to April 25th. We had one small change. It looked benevolent. It was internally contributed by a Grafana employee. Looked a lot like CI improvement. What happened, though, is we had pull request moving to pull request target with a combination of this script request. So with that, the user checked out the code, made a pull request against us, and GitHub Actions executed the command. And this is the combination that mattered. So any contributor could then run arbitrary commands against our secrets. One merge is all it took, and the door was open. And I want to highlight this line right here. So again, if you're familiar with GitHub, it has a lot of built-in features. GitHub repository automatically populated, GitHub SHA automatically populated. GitHub headref, though, that's GitHub speak for the name of your branch. That's what it took. This was the attack vector, and this is completely user-controlled. So the payload here, it wasn't something fancy. It wasn't a 0-day with sophisticated, well, obviously it was a hacker with a hoodie. We all know that. But it wasn't sophisticated in any other way. The payload was a branch name. We've looked at the door now, or introduced the concept of the door. What did the key look like then? So the attacker used Gato-X. We know this. We'll get to it a bit later. But Gato-X is a tool designed to be used at scale. It scans GitHub organizations at scale. It finds vulnerable GitHub Actions workflows. It maps them, and it actively tries to exploit them. This was done in a 3-step process. First step was get access to the fork. Hey, we're an open source company. That's easy. Step 2 was to trigger the workflow. Do the PR against our repo. Done. Step 3, get creative. So with that whole malicious payload, they now could enumerate, they could exfiltrate, they could do a lot of nasty things. And as I mentioned, the branch name was a payload. It looked like this. It's embedded in dispatch check patch conflicts main, a request to do a curl command that downloads a GitHub gist, which contained a lot of nasty stuff. So this is automated. It's fast. It runs across multiple repos. And in any repo, it gets access to our GitHub environment variables. And if we have a GitHub token with tightly scoped credentials, that's bad. If you have a GitHub token with broad tokens, well, it's even worse. Let's leave it at that. So,
and what made this impact really, really bad was the way we were storing secrets, which is the way most people store secrets in GitHub, is we were using GitHub secrets. Unsurprisingly, right? It's in the name. That's where you put your secrets, right? And GitHub secrets is very liberal in how it approaches storing and providing secrets. You've got a secret. Here, have it. Have the secret. It's not that secret, right? Oh, maybe it should be. Oh, well, never mind. But yeah, it just gives away secrets to everything available. It puts them immediately into the environment without any additional checks or anything like that. So if you have a script like that that then fetches all of the environment, you're getting everything. And that's a real risk. We had actually done some migration. Some of our repos had moved their storage of secrets into Vault. HashiCorp Vault, I'm sure many of you are familiar with it, allows us to store secrets and provide them to GitHub workflows. But it's a multiple gate jumping exercise to get them. You have to go fetch the right ones. You have to have the OIDC token to be able to request it in the first place. It gets in the way. It slows down an attacker. And it doesn't provide you all the secrets for free immediately. Where we had migrated, this impact was minimal. But unfortunately for Grafana, we hadn't at that point. And that's where we saw the attack happen. So the attack timeline is pretty simple. 1640, the PR was open to add this change. 1752, the change was applied, and we were immediately vulnerable to anyone running Gato-X and executing this, which is actually not immediately what happened. The first thing we had was a report from a security researcher. We have a bug bounty program, and we got a well-meaning report where they pointed out that this was actually vulnerable. Unfortunately, bug bounty programs are slow to turn around. We take a while to actually process them. We didn't see this immediately and weren't able to respond to it. And then after that, at 4:30 the next day, we're seeing the actual attacker execute Gato-X and start exfiltrating our secrets about 10 hours after the original door was opened. So within 10 hours, the attacker had identified this vulnerability and was immediately using it to actually steal our secrets. This is where we got a tiny bit lucky. Our attacker decided to actually try and explore the secrets they had, see what they had. And when they did that, about 16:15, that's when they triggered our internal alerting. And that's where we got involved and started digging into it. And we're going to talk about how we actually found that immediately in a moment. After that, it was then a whirlwind of response activities, which took the weekend several weeks later. And so we used a bunch of tools as part of this. One of the key parts was IRM. I'm sure many of you are familiar using IRM. It's a great tool we use internally for normal operational instance, but also security instance, managing coordination, communication, and making sure everyone's on the same page when these kind of attacks happen. We really heavily use Loki. A large amount of our logs, all the key logs for our incident went into Loki, and we were able to query and find them and understand what happened. We brought in loads of open source tooling. We brought in Zizmor. This is a tool to automatically verify whether or not your workflows in GitHub are vulnerable or not. We used TruffleHog to try and find out, have we actually got any secrets that might be vulnerable in the repositories? Have we placed secrets in repositories? And we rectified those as part of it. And we also used Gato-X, the hunter-turned-gamekeeper. Gato-X is the tool the attacker actually used. And it's great to be able to verify you're not vulnerable by using the tool the attacker was using. So as I said, IRM was a key kind of cornerstone to the entire response process. It really enables easy communication. We use them for security and operational events. And it's available to everyone for free in Grafana Cloud. It's got really close integration with all our tooling like Slack and Google Docs, just simplifying communicating to everyone who's involved what's going on and making sure they're aware and informed as necessary. And of course, we integrate Grafana alerting tightly into it, so we were able to move from alert to incident really easily, and keeping all that context together, making sure that the people who needed to know what happened knew. Loki is, of course, our log storage database, and we use it very heavily throughout this incident. All our key logs from GitHub were being written not only to GitHub storage, but also to our Loki. And this was actually really important. Attackers can delete logs from GitHub if they have the right permissions. Logs expire. We have our Loki instance configured to make sure it retains our logs, so we can actually go back and look at them and make sure, understand exactly what had happened and see the full extent of the compromise. An incredibly powerful query language as well. The query languages provided by tools like GitHub are really quite limited, honestly, and really don't allow us to investigate properly. But with Loki, we could actually dig into our logs and really find the vulnerabilities and find the evidence of where those vulnerabilities had been applied.
Moving on to Zizmor, another tool in the open source ecosystem. This working in the open source ecosystem was extremely helpful in one of these situations. The tools were available to us immediately when we needed them. So a GitHub Actions workflow is essentially a code file. What Zizmor is static analysis specifically for those kind of source codes. What it does, it flags certain behaviors, certain patterns, so it immediately flags pull request target and says that this is almost always used incorrectly. So please take a look again if you really need this. But it also detects unpinned actions. So for example, the last couple of weeks, we as an industry have seen a lot of supply chain attacks. This is something that Zizmor detects again. But also other things, injection vulnerabilities, and a bunch of these things. What we did during the incident was, all right, we know that they used one GitHub Actions workflow. We have more. Are we vulnerable in more places? So we started scanning all of our repositories, internal and external, with Zizmor. We got a list of prioritized findings. These are the things you need to look at immediately. And from there on, we started to fix finding after finding and re-enable workflows for each repo as they were fixed. Needless to say, this now lives in our CI and is a mandatory control. The fun thing, though, as talking about open source again and again, the fun thing is that we actually started contributing to this. Our team implemented an automated fix suggestion for Zizmor. It's an immediate outcome of this incident. TruffleHog, we've also spoken a bit about this, a tool that was in fact used by the attacker. But in essence, it's a dual-use tool. It can be used for good and bad. What it does, it finds secrets, and you can ask it to verify these secrets against live services. So for example, if you find a secret that is supposed to be a GitHub token, you ask GitHub, is this a valid secret? Is it up to date? Same goes for AWS and all other secrets and tokens that you can get your hand on. From a log perspective, it looks a lot like normal auth traffic. So it doesn't stand out in terms of normal log analysis. But since one of the tokens they got access to was a Canary, that is what triggered us to respond to this. Neither of these tools replaced human judgment, but it sped up our response from days to hours. And obviously, we have to talk about Gato-X. This was the attacker's tool, and actually our tool during response. So in a way, it's similar to Zizmor. It scans for vulnerable GitHub Actions workflows, but it takes it one step further. It actually tries to exploit them. So it maps the paths, it tries to execute them, and running it ourselves, well, it gave us an attacker's eye view. So finding the list using Zizmor gave us a netlist to fix these things. Then we tried Gato-X. Is there something that we have missed? It's extremely disorientating to do during a live incident, but it's also very, very useful. But a question I would like to leave you with in regards to Gato-X is, assume that these kind of tools will be used against you. So are you running it yourself first?
I should probably say that also the logo there we're using for Gato-X was not Gato-X official logo. There isn't one, sadly, but Gemini's best attempt at what it might look like. It did not a bad job, I think. So how did we actually find this in the first place? And we did this thanks largely to security Canary tokens. So Canary tokens are a really simple idea. You create tokens that really have no permissions. They can't do anything at all. They're limited in access. They only have access to an empty project. And they aren't able to do anything anyway. But when anyone uses them to authenticate in any part of your system, you set an alert. You send an alert to the security team. And that's exactly what we have distributed all the way through all of our infrastructure. They look just like juicy AWS keys, something an attacker loves to find. But when they pull the top off and try to do anything with it, that's when we get alerted and find out that it's been compromised. This really changes the dynamic for a hacker. Okay? Without canaries, they're a child in a chocolate factory. Every tasty, sweet-looking treat is available to grab and delicious without consequence. But if they're there in your environment, suddenly the world changes. It's a nightmarish, parallel Willy Wonka, Gaudi-esque hellscape, where all the sweet treats suddenly also could be poison, worrying that anything they touch might make them blow up, like a giant glowing orb visible to everyone. And it was actually thanks to TruffleHog's validation feature that we found this attack. TruffleHog tried to validate our Canary token, connected, made an authentication attempt, and oh, we're getting alerted about it now. Though I will note that if you are using, sadly, Think's free offering in this space, TruffleHog knows how to pick it up, and it will actually not try to validate the free thinks token, sadly. Annoying. So the response pipeline, as we said, 0430, we had the attack event. Gato-X was used to compromise Grafana, stealing all our tokens. Our Canary token then fires at 0615, where they use TruffleHog to validate the tokens and fired our Canary token. We kicked off an incident at 0800, having understood the breadth of the compromise and the importance of it. And IRM was, of course, integral in that response. We started digging into all our logs and fully understanding the breadth and full depth of that compromise by 1100 using Loki. And then over the next day and continuing days, we started using Gato-X, TruffleHog, and Zizmor to try and make sure we weren't going to be vulnerable to this again.
And obviously, we wouldn't be at GrafanaCon without having at least one Grafana dashboard in our presentation. This one is specific to TruffleHog, but we have similar for Zizmor now and other relevant tools. And specific to TruffleHog, just because you've blocked a PR in your CI, that doesn't mean that it's safe. The secret is still there in a Git log somewhere, so rotation of that secret is mandatory. Having it block is one thing, but getting this kind of observability, that makes it actionable. You can build alerting features around it. So as you see here, we have 192 repos have been scanned with 666 scans run in total. And scans with findings, 7. But these are all known things that we want there. The important thing here is verified secrets, 0. And if that number ever were to go up, automatically we would get an alert and be able to start working on that, rotating, making sure that the secret has been rotated. Goes without saying, but detection without visibility, that's noise. This is how you turn findings into action. All right, to recap, what went right? What were the lessons that we learned? Preparation beats reaction, every time. Canaries, static analysis, secret hygiene, all of that makes you be able to respond, not react. And observability, it's not just something you have for production. You need it in CI/CD as well. And don't just take our word for it. Adnan Khan, the author behind Gato-X, said, "Ooh, looks like Grafana was hit by an attack recently." We were able to respond within a really, really short time frame to this tweet, and then got this response. Kudos to the Grafana team for breaking up the attack. CI/CD detection engineering is non-existent most places. Should be good for others to learn from this. Open source is a security advantage, not only for attackers, but by defenders too. And the no customer impact post that Nick alluded to earlier, you earn the right to make that post by doing the work beforehand.
So the lessons we learned, well, we moved all our secrets from GitHub Secrets, as easy as it was to use, into Vault. It was a more secure environment that was harder to use and introduced a bunch of pain to a bunch of our teams, sadly. But it was the right choice. And we'll talk a bit more why that was in a second. We implemented mandatory Zizmor and TruffleHog scans. Every PR against any GitHub repo in the Grafana org will automatically have Zizmor and TruffleHog run against it. And some of you may know, you may have seen it yourself. We broadened our Canary token coverage. You can always have more Canary tokens. They can just go anywhere. So we dropped them around, just trying to make it a bit more hellscapey for those attackers. And we really reduced one of the impacts here we haven't talked too much about is GitHub apps. And how broad their accesses can really be a significant impact. And we really shrunk those. We broke down existing kind of super users that were able to access anything and really reduced their accesses. And of course, we had to do a bit of user education. Okay, I hold my hand up and say, I am not a GitHub workflow security expert. I have an understanding of it, and I have learned a lot over the multiple incidents we've encountered at Grafana, but very few people are experts. And it's really easy to miss those kind of little weird edge cases that you wouldn't necessarily think to be a problem. And that education meant that actually when we had similar incidents again, as many of you may know, there was an Aqua security breach where their Trivi scanner was compromised and a supply chain attack against many people. Axios, in a similar way, got hacked in a very similar way. We got touched by these, but we were not hit by them. And what I mean there is that because of the work we've done to limit the scope of attack access and so on and so forth, we really prevented the attackers who hit us via these from actually stealing anything. And we were able to verify that within hours, not weeks of effort, which significantly reduced their cost. And with that, we are finished. Thank you very much.
Thank you all.